the tube light in your home or any electrical bulb, tube light, or nowadays we have a trend, LED bulb, anything, let it be. So such a bulb, so when it is glowing, so a tube light or an LED bulb is glowing, that one. Nearby it or at a certain distance. So just stretch your arm, stretch your arm, and so let it be on the floor or on the wall, whatever possible, that one. And try to see the shadow. Try to make observation of the shadow formed by your arm or your hand, that one. So you have to place against the light emitted by the tube light. This will be the path. Let me adjust. This is, yeah. This will be the direction of ray of incident light. And we know this hand is an opaque object, no? So our body is an opaque. So what it does, it will block the any light, that one. So what do we expect? We expect a shadow. But if we just closely monitor the shadow, which is formed on the floor or on the wall, you can definitely see that you don't see the complete shadow, that one. So you see the inner part of the shadow will be completely dark, and the outer edges, what happen, will be of like in a gray color or less dark. So some light entered. So here this will be completely dark and here will be less dark, that one. So any reason for that? Why the shadow like this? Okay, let's not go for in detail about the details of shadow. Just we are more bothered about the diffraction. So definitely I can say that here, when the ray of light, it encounters the edges here, the surfaces, this part. Here open, it will bend, it will starts bending. Means, so what is the diffraction? Bending of ray of light when it encounters sharp edges. When sharp edges will come, no, so it will start bending. So due to that bend, what will happen? Some light, what happen, will enter into this region. Actually, it should be completely dark if there is no bending of ray of light. Because of bending of ray of light, some light will enter into this outer region. And because of that, what happen, it will not be completely dark, semi-dark you can call it. There'll be some intensity of light. Here, intensity of light will be zero. This phenomena is called as a diffraction. I think this everyone can experience, not only just your arm. You stand in sunlight and try to look at the shadow. So at the middle region, you can see completely dark, absence of light. Here, some presence of light. This region, so there'll be an absence of light, total absence of light. What about here? So some light will enter into this. There's nothing but some encroachment. The ray of light, what happen, will encounter when it crosses through the fingers here, some sort of like a, it will see like a edges or the surfaces here, it will encounter bending of ray of light occurs. Due to that bend, what will happen? So the light will enter into this region. Okay, please do experience. I'm just sharing my general view on the diffraction after this. Okay, now we'll take the another situation. Let me keep a wood. We know wood is a opaque object. So what is the wood? Wood will practically will not permit. Wood is a opaque body. So what do you mean by opaque? Which will not transmit light through it. Okay, fine. So let me keep here a bulb, electric bulb glowing. So which will emit while LED bulb. Okay, let me go for still LED. So because now the trend is LED. So the tungsten filament bulb almost, I think it's over. So let me keep that white light, a source of white light. Yeah. So then what happened? According to theoretically on paper, this is on paper theoretically. So what do we expect that ray of light, this goes undeviated. And what about here? Here light is present. So definitely open, this is a screen. So that everything is a screen. So which part of screen will be illuminated? As everything is a screen. So here from B down, the screen will be illuminated because the light is entering, the light is incident. What about here? Here also the light emitted by the LED bulb will be incident. Here it will be like a complete shadow or a complete dark. So what we see here, a complete dark region, a complete dark region is what visible here. Means why that complete dark? Because the wood will not permit. There's a theoretical, so what we are putting is expected according to the geometrical optics. Because what is geometrical optics? Rectilinear propagation of light. Light will propagate like it will have rectilinear propagation. So fine. Or so why there is no light here? Because the wood will block the light. So all the light that is coming in this region will be blocked by the wood. So finally, only due to rectilinear propagation, only this part of screen should be illuminated. Will I agree? Yes, this is what we expect. Okay, let's do one thing. Practically, when you go and check it, hmm, so this part, the ray of light which is incident in this region, is very much it will be blocked by the wood. And the ray of light which is present in this region will go and illuminate this part of the screen. I see this screen got illuminated. Here also similarly at below B, the screen will get illuminated. So what do you expect is like here complete dark. Then in this region, you don't get complete dark. There'll be some presence of light. Means here intensity here non-zero, here intensity zero, and the intensity from year to year will vary. From zero, it starts increasing. So how come the light has come here? According to rectilinear propagation of light, it should propagate in a straight line, straight path. Don't say straight line, straight path. It should just propagate in straight path. Then what made the light, to enter in this region also? It is just due to diffraction. What is the diffraction? Because here you can see this. I'm moving the spot, make observation. So you can see some sort of like a sharp edge here. No? So the light encounters a sharp edges. Then because of that, a bending of ray of light occurs. So here what happens, this will start bending. Till here it will propagate in a straight line path. Here it will encounter diffraction or starts bending. So when it starts bending, some light will move up, some light what happened will trace a path in this direction. So what is happening here now? Bending of ray of light is occurring in this region. So encroachment, hmm, some amount of light is present. According to rectilinear propagation here in this region, no light, complete dark. But this is what we think. But practically, if you go and check it, no, so it will be like a semi-dark. There will be some encroachment of light will occur. Means, sir, can you say about intensity? Here zero, here okay, very good. Suppose like a 10 watt per meter square. What do you expect here? From here, as you start moving, the intensity starts varying. 1 watt, 2 watt, 3 watt. So some variation will be there. So how come the light entered here? How come the light entered? We have to ask questions, sir. Why A dash? There also light is reaching due to bending of ray of light. Here, this region. Here, the bending of ray of light will occur in this region. The same thing happens here also. Theoretically, yes, it should just reach only be darker region. But here, due to encroachment of light, due to bending of ray of light, even the light reaches in this region B dash B. So in this way, what will happen? This particular phenomena, bending of ray of light at the sharp edges, is called as a diffraction. This is what we are going to study here. Okay, what is the thing is, okay, there's one more example. Let this be a slit. So what we have is a, let me adjust things. Okay, what I'm bringing, it's a slit. Diagram not clear, so let me make it. So this is slit. Yeah, I think it'll be completely very easily visible. So here now, what do you mean by slit? Some narrow opening, some small hole. So here I kept a point source of light. So this is point source of light. It will start emitting light. So this particular slit made up of opaque substance like a wood or cardboards or any other substance like a metal, which will block the light here. Here hole is there. Through this hole open, the light will pass through the hole and will illuminate the slit. So according to the theory, what we know, so the light will spread. So what do we think that only in the region AB the screen should be illuminated? But here what happened? The bending of ray of light occurs at the edge, because here the slit edges will come. So here the light will bend and it will start encroaching. So theoretically, so what we think, according to linear propagation of light, complete dark, bright, complete dark. But practically what happens? An encroachment of light will occur. Means here the light, when it enters this sharp edge, it starts bending. It was supposed to move like this, so it will bend. So definitely here intensity, what we think, 0. But according to diffraction phenomena, it will be non-zero. Less light, no light. So this is a completely dark. I'm unable to write anything. Let me put it here. Completely dark. So this also completely dark. And here anyway, the light is passing through the slit, it will get illuminated. More light will be present here. And because the encroachment is not only in this direction, will also occur in the air like this. So definitely what you expect here, the intensity here will not be uniform, will be variable, because the just not only who will reach the region AB, not only this part of the ray of light, even here open, the bending will occur like this in all direction. So definitely will not be uniform intensity, some variable intensity what we are going to get on the screen. So this region is what the concern. According to the rectilinear propagation, this everything should be complete dark. So this should be the complete bright, and again the complete dark. But due to diffraction, there'll be bending of ray of light. So therefore, this diffraction phenomena, is it obeys rectilinear propagation of light? The answer is no. So it supports the wave nature of light. Fine. That's what I'm slowly going to the original idea of this one. So the bending of ray of light is nothing but the wave nature of light is what coming to picture, because the wave will bend. A good example, the sound wave. Suppose I'm teaching in one of the classroom. How